This is Mr. Agbamu Idanobrene. I'm here to teach you how you can solve questions on bearing in WAEC examination. So all I need to do in this video, I just want to introduce you to bearing, just give you some brief introduction, and from there we'll solve these few examples. Then I'll prepare more complex example in my next video. But let me start with these basic questions. If you understand this, I'm telling you the truth, you're not going to have any problem with the topic bearing. Just follow all I'm going to show you and you see that the topic is very simple. So let me start by showing you this. Okay, so this is a kind of compass. You can see the various points are labeled. You see the north, you see the northeast, you see the east, southeast, the south, then southwest, then west, then north, south. So this is the various directions we have in bearing. Bearing is all about the angular direction from one point to another. For example, you are moving from this point. Let's say you are standing on this place. You want to move to another point. You have to turn. And the assumption in bearing, the basic assumption in bearing is you are always facing the north. That is why you see the red arrow is facing the north, and your angle is always 0 degrees north, 0 degrees due north. So that is the basic assumption in bearing. And when you want to turn, when you want to make your movement, your angular turn, you must turn through the east, not through the west. You must always turn through the east. That is the assumption in bearing. By the time you get these basic assumptions, I'm telling you the truth, you have settled almost 50% of the topic. The next knowledge you need to have in bearing is application of basic trigonometric ratio, the sine, the cos, and the tangent, and the sine rule and cosine rule. You should be able to apply sine rule and cosine rule in solving the length and angles of a triangle. If you know that, then you are good to go. But this very video, I just want to introduce basic location of point and angular turn of bearing. If you understand it, you have no problem. This is what I wanted to take note of. As I said earlier, in bearing, you always face the north. That's the assumption. Anywhere you are standing in the earth surface or anywhere you are located, you are always facing the north, and your angle at that point is 0 degrees. Then let me rotate the needle so that you can see. Then as you turn, you must turn through the east. You can see the red arrow. You can see it's going through the east, and your angle will start counting. Then when you turn to the angle you wish to turn to, then you move through that direction. For example, let's say you are turning to angle 20 degrees, bearing of 20 degrees from this point. That means you are going to face this place and move through this direction. I'm going to explain it better with examples so that you understand what we are saying. But I just want to use this to explain to you the movement, the angular turn of bearing. So this turning now, you can see the red arrow is in the northeast direction. So this is the northeast direction, and the angle, the various angles you can get in the northeast direction, they start from 0 down to 90 degrees. So 90 degrees is the highest you can get in this direction, 0 to 90, so in the northeast direction. So if bearing is given as northeast direction, so if you know that your angle can never be greater than 90 and your angle can never be less than 0. So if bearing is given in the southeast direction, that means you can see southeast, your angle is between 90 and 180 degrees. You can see it here. So your angle can never be greater than 180 and it can never be less than 90. That is southwest direction. See, you are facing south, then southeast direction. You are facing south, going towards east. See, so your angle will be around this place. Then if it's southwest, see, you are facing south, then you move towards west. So your angle is going to be from 180 degrees down to 270. You can see it here. So 270 to 180, that is southwest direction. So take note of that. Then the last direction we have, which is the northwest. So you are facing north, west direction. See, facing north 0 degrees, then west direction. But the major assumption I want you to take note of is you are always facing north. Anywhere you are standing in bearing, you are always facing north. Then you turn through the east down before you start your movement. So take note of this. So before we solve the examples I laid down for us, I want to use this video and this animation I have here to explain this analysis. So you see what I have here. This is true bearing. True bearing. What I mean by this true bearing is this. This man, you can see, is facing north. See, this is the north. It's facing there. So this man want to locate this dog. He want to go to the position of this dog. So how does he move? He must turn through the east like this before he will start moving to this place. Then the angular turn is the bearing from where this man is standing down to this dog. So the bearing of this dog from this man, the bearing, you must take note of where you are coming from. It is where you are coming from that you turn. It is the position of where you are coming from, you do your angular turn. So you are coming from this man down to this dog, so you are going to turn through the east direction. So we call this true bearing because it's the 3-digit bearing. If I click on the show now, just watch how this man will turn through the east down to this dog. You can see how it's turning, then he got to this place. Then when he turns this angle 259.9 down to this place, then it will now move like this. So you can now say the bearing of this dog from where this man is located is 259.9 degrees. So that is that. So if the dog is somewhere here, you can see the bearing of this dog from where this man is. You can see all the turning from the north through east, south, west, and get to this place and down here. So this is true bearing, which is also called the 3-digit bearing. You can see them 1, 2, 3. They're always in 3 digits. If you put it here, you will see the 3-digit 1, 2, 3. So this is 3-digit bearing, which is the true bearing. Everything must come from north. You turn down to here, then you start moving through this direction. So that's why we say bearing is the angular direction of an object from another point, from another object. So from this man to this point, the bearing is the angular turn. Then you start moving straight. So take note of this. Then sometimes bearing can be given in cardinal form. Yes, bearing can be given in cardinal form, not in this form. So when bearing is given in the cardinal form, which some people also call the compass bearing, you can also call it the compass bearing or the cardinal form bearing. So if bearing is given in compass form, all you need to know is the direction the person is facing or the direction you are facing. Let me show you this so that you understand it, which is this. You can see this cat. So this cat is facing the south direction. So this man is facing the south because this is a compass bearing. See, as long as this cat is facing south, it's in the south direction. All this region are the south direction. So this man will keep facing south. Then if the man want to move to this cat, so it's going to move southwest direction. See, southwest direction. So just watch. You can see it. So that is south 66 degrees west. You see, south 66 degrees west before it came down. So this is cardinal bearing, or we call it the compass bearing. So as long as this cat is in any region around there, you are going to have south west direction. So this is southwest. So this is southwest. Then this side will be southeast. See, southeast. So this side is southeast, while this side is southwest. So take note. Then immediately this cat moves up to north. Just watch. So you move up to north, it has turned to northwest. So this is western region of north now. So you are facing north, you turn 75 degrees to the west. See, so all these region are northwest region. Take note of that. Very, very important. Then this side is northeast region. You are facing north. You turn 42.9 degree towards east. So very, very important. So that is this. So if I reset it, this man is moving to this door, to this cart. So it's facing north. So this is northeast direction. So it's going to turn north, then turn 68.4 degree east. So take note of this. So with this basic knowledge, you can answer these 4 basic questions I have here. They are WAEC questions and they are objective questions. They are simple questions, but I just want you to get the basic knowledge of bearing, and you see that they are simple. Look at the first one I have here, taken from year 2000, number 16. We say, which of the following bearing is equivalent to south 50 degrees west? South 50 degrees west. You can see the options here. What does this one mean? It means you are facing south and you turn 50 degrees to the west, which is something like this. Okay, this one. That means you are facing south. Then since it's southwest, that means the object is somewhere here. So if you now put it like this, you see, so facing south, so we are talking of 50 degrees, which is somewhere here, 50 degrees south. So this is what it's talking about. So this is southwest direction. So now the question wants you to find the equivalent, that is the 3-digit bearing now, which is the true bearing. So what is the true bearing of this? The equivalent of this in the 3-digit form, which is this one now. So you know that the answer is somewhere here, but how do you know the exact true bearing that will come from here all through the eastern side down to south and down to this place? What particular value will you get that will be equals to this same value you have here? So in order to solve this, you know you cannot take a system like this to your exam hall. So in order to solve this, all you need to do, just go to your paper. Let's go to our notebook. So let's take this as your notebook. It's very simple thing. Get your pen. Let me take a small thickness. Okay, I think this is okay. Just draw your line. Just draw your line. So we already know that this is north. So this is north. So you're always facing north. Then this is south. So you either have northeast or northwest, or southeast or southwest. So depend on how the question comes, or if the question comes in 3 digits, so you already know how to move. But this question is in cardinal form, which is a compass bearing. They want you to find the equivalence in 3 digits. So without wasting time, this is all we just need to do. So you are facing south, which is something like this now, 50 degrees west. So the 50 degree is here. So how do you get your answer here? Very simple. If we said bearing, north is always 0 degrees, east is 90 degrees, south is 180 degrees. So from here, if you turn around, this is 90 plus another 90, that's 180, then plus 50. So your answer is very easy. You can just take 180 plus 50. So this is your answer, and that is all. You know, it's an objective question. You just tap your calculator or you use your solving solution paper and you get your answer fast. Or you say 90, which is the first region, 90 plus another 90, the second region, plus another 90 plus 90, then plus 50. So this is the true bearing before you start moving to where you are going to. So this is that. So we say plus 50. So these two will give us the same answer. So anyone you wish to solve, you will get the same thing. So without wasting time, if you add 90, 9 plus 9, which is 180, 180 plus 50, this is going to give us 23, that is 2/3. So that's all. So the answer for the first one is 230 degrees. Take note of that. So my answer here is this, that is 230 degrees. Okay, let's look at this. So the second question is similar to this. There are so many in the past questions. I just picked these two. You can go through your past question and you understand it very well. So this is south 40 degrees east. So south 40 degrees east. So let me just erase this fast. So this is south 40 degrees east. So the same thing, same approach. All you just need to do, get your pen, go to your paper, draw your 4 cardinal point. We say south is down. You turn 40 degrees towards each direction, you move. So that is it. So 40 degrees is here. So you are facing south, 40 degrees towards east. Then the true bearing is this. This is, you have your 90 plus the remaining angle. And you know that each of these cardinal points are all 90 degrees, 90 degrees, 90 degrees. So each of them are 90, 90, 90, 90. So if this is 90, if this region here is 90, then this full region also is also 90. Understand? This full region is also 90. So 90 degrees minus 40 degrees. So this place is going to be 50 degrees. So your answer is easy. Just say 90 plus 50 is the answer to this question. So the true bearing, the true bearing of this will just be 90 plus 50. 90 plus 50. So you can add this 9 plus 5. This will give us 14. That is 140 is your answer. So 140 degrees is the answer. Or if you don't want to do it like this, 90 plus 50, you can do the full angle. Since the full angle is 180, from 0 degree north down to south, it's 180 degrees. So subtract 40 out of the full 180 degrees is the same result you will get. So 180 degrees minus 40, you get the same result. Take note of this. So which is 18 minus 4, this will give us 4. So that is off. That's 18 minus 4 is 14, sorry. 18 minus 4 is 14, then 0. So that is it. So take note of this. So that is the answer to these two questions. So this second one, the answer is also D. And that is 140 degrees. So take note of that. Let's look at number 3. Taken from 2004, number 29 objective question. So this is this one. Now we have 2 points, x and y. So you need to know where you are coming from. So where you are coming from is where you will do your angular turning. So it said a point x on the bearing 342 degrees. So we are not coming from x. The question did not say from point x. It's just telling us where you can move to get to x. So that's why I say a point x is on the bearing. So it's on this bearing. So you are not coming from x, you are just on that bearing. So where are you coming from? If you read further, it said from a point y. So x is on this bearing 342 degrees from a point y. So what you are going to draw down first is your point y. Let me erase all this. Erase this. It's your point y. So you come down, take your rough sketch. As we said, this is your north, and bearing must go round through the east. So this is 90 plus another 90, 180 plus another 90, 270. No, we are going to 342. So 342 will be somewhere here. So we move straight. So that is it. So this is 342. So that is the angle. That's your turning. And this is point y. You just need to label it. So that is it. You can see it. It says a point x is on the bearing 342 degrees from a point y. So we are turning from y. So since we are coming from y, so y will take the angular turn, and that is 342 degrees. So 342 degrees from north, you turn round down to this place, and you take note of that. Alright, so that means X should be standing somewhere here. You just come and draw your straight line. So X should be here. So this is X now, this is point X. So X, this is also the north of X. So this is also the north of X. Now, what is the question saying now? What are we solving? You say, what is the bearing of Y from X? So now, when you want to return back now, from X, now you want to go back to Y, what will now be the bearing? So this is it. So coming from Y to X, you turn 342 degrees. Now when you want to return back from X down to Y, so this is the bearing you are going to turn. So you are going to turn 90 plus this extra point here. So this is the place you turn to before you move. So this is the value they want us to find. So how do we get this value? So without wasting time on this, remember what I said before. Each of these cardinal points, they are all 90 degrees. So this is 180. So this point here, so this point is 270 degrees. 270 degrees. So this is 270. So that is west, 270. So you have already turned 90, 180, 270. Then you now turn a little bit extra. That gave us 342. So if I want to get this angle here, all I just need to do, I'll subtract 270 plus 342. So from 342, so 342 minus 270. So what will be our result here? So let's subtract now. This is 2 will be here. Yeah. Then this is 14 minus 7 will give us 7. Then this is 2. So the answer is going to be 72. So this place is 72 degrees. So you understand? So 270 is up to this place plus 72 is going to give us 342 degrees. So you know, as we said initially, this is the north, this is east, this is south, this is west. The same thing here. This is north, east, south, west. So all these points, this north line is parallel to this north line here. This east line is parallel to this east line here. So as long as this line, this horizontal line, the east-west line, is parallel to this east-west line here, that means 72 is also equal to this place. So this is alternate angle. So this is alternate angle. 72 is also equal to this place, 72. So if they are equal, what do I need next? This is 90 plus 72 angle, and that will give us the bearing from X to Y. So that is the result now. So if I put my answer, let me reduce the font here. So now the bearing, so the bearing of Y from X is, you just add 90 plus 72, and that is going to give us what? So that is going to give us 162. Or am I okay? It should be 1. Let me check well. 10 minus 2, we have 8. Okay, we are adding, sorry. We are adding, I'm subtracting. So it's correct. So 9 plus 7 is 16. Then we have this. So this is the result. So this is the bearing of that. So the answer is 162. But I just want you to understand, it is this turning that is very important. From Y to X, you turn around 342 before going to X. Then you also have your point, your north, east, and your west line in the X. Then from X, when you are going back to Y, all you just need to do, you also turn from east down to this place and you come down. Then the major thing that you need to do here is this 7. You need to know this 72. 72 is alternate to this side 72, since the horizontal lines, they are parallel lines. That is the north, the east-west lines are parallel to the east-west line. So take notes of this, it's very, very important. So if you check your options, you are going to see it there. So the answer is D, which is 162 degrees. So take note of that. Let me even demonstrate this one we just did now. Let me demonstrate it using this GeoGebra I just set here. So if let me label this as let me just label this as point X. I just want you to get something out of this. I want you to see a kind of picture of what we just did there. So let me call this one point Y. Alright. So let me take this out. I don't need this for now. Okay, so I have 2 points X and Y. I want to move. So now I want to turn 342. You see, just watch the way I turn this place. Let me zoom it up a little so that you can see it well. Distance is not given in this question, it's just the turning. So you see, you turn down till you get to 342, you stop. Till you get to 342. Okay, so this is where we are now. So 342. So before we can move it, that means point X should be somewhere here. Let me connect them with a line. So if I join this to this, that means the actual turning is somewhere here. Let me move it. That means the actual turning is somewhere here. Yes, you can see it. You turn 342 degrees before you move to X. Then now when you want to return back to X, you're supposed to turn 162. That's what we calculated. So let me turn X so that you see it. So X will turn down to, you can see it, 162. Perfect. Before you come down. So this is the movement we are talking about. So you can see that it's very correct, the calculation we did in this place. So which is 162. Just wanted to see this animation so that you understand it. Y turns 342 before going to X. So when you want to return back from X, you turn again through east 162, and you return back to Y. So this is how we do the calculation of that question. So take note of this. So let's do the last one, and that is the end of this video. Then in my next video I will do more calculation, much complex ones. But with this introduction, I know you will have no problem with bearing. This is the basic introduction of bearing. All bearing questions must have points, and you must move from one point to another point given the bearing. Then they may ask you to calculate the length. I don't have any calculation on length here. That will be in our next solution video. I'm going to solve some questions on length. That is where we are going to apply Pythagoras theorem or trigonometric ratio or sine rule and cosine rule. So this last question says the bearing of P from Q. So let me start with this. So let me just go to a new page. There your paper. Let me draw my first point. The question says from Q. So let me label this point as Q. So this is Q. So I'm coming from Q. P is not where you are coming from. Always read your question, very important. The bearing of P from Q. So you are coming from Q. So Q should be the point you are drawing now. So this is point Q. So this is my north. Remember the law, you must turn through the east. So let's see. So the bearing is X. So we don't know the value of X. So we cannot turn yet until we know the value of X. You know, this is WAEC question and it's a standard question. So they must not give you what will be confused or what will confuse you. So they gave a condition for X. Look at the various ranges for X. They say where 270 degrees is less than X, you see, and X is less than 360 degrees. That means X should be between 270 to 360 degrees. That's what this question is talking about. Because 270 is already less than X. That means all the numbers that X are greater than should start from 271, 72, 70 down till you get to 359. So X lies between 270 and 360. So that means my turning is going to go like this from north 90, 180, 270, So it's around this region. So x is going to be around this region, but we don't know the value yet. So let's just go straight. So this is angle x that we just turned, but we don't know the exact value, but it's around this region. So from there we move to the next point, which is point P. So that is point P. Alright. So this is the turning of x between 270 and 360. So this region. So you have turned. Now what do we do? Remember what we did in the previous examples. The parallel lines, this is horizontal line, is parallel to this. Then the north-south line is parallel to this. So take note of alternate angle. In bearing, we don't joke with alternate angles. We have alternate angles that are always equal. But let me go back to the question so that we know what to do next. Okay, if you look at the question now, they said find the bearing of Q from P. Find the bearing of Q from P. And if you look at all the options, you see X is in the options. So we need to choose the right answer to pick. Alright, let's start now. So we are coming back from P back to Q. That is the bearing the question demands from us. Okay, so that is this. So from P, when I turn around 90 plus this value here, is going to give me my bearing from P back to X, which is from P back to Q, not X, sorry, from P back to Q. So since all this value here is X, and remember this point is 270, this is 270. So this value is 270. So X minus 270 will give me this result I have here. So this angle here is X. X minus 270 is this angle in this place. Very, very important. I think you can see it clearly. And that angle is equal to this value here. To X minus 270. So that is the alternate angles. So this angle X minus 270, you know X is the full angle. Take away 270 out of it, you will get this place, X minus 270 is going to be equal to this angle here, X minus 270. Why this is already 90 degrees? This is already 90 degrees. So your answer for the bearing now is, so the bearing of Q from P, coming from P now, is going to be 90 plus. So we have 90 plus x, 90 plus x minus 270. So without wasting time, our result for this is going to be x. Since x is not a like term, so x is a variable, is on its own. So we have 90 minus 270, and that is going to be negative now. So 90 minus 270 is going to be negative 180 degrees. So, and that is the result to this question. X minus 180. So that means the answer to this question is D. X minus 180 degrees. So that is the answer. X is X minus 180 degrees. Okay, X minus 180 in brackets. Alright, so that is the answer, which is D is the answer to this question. So D is the answer. So this is all I have for us in this video. So this is the basic introduction to bearing. Please take note of it. It's not difficult. If you know how to locate your point in bearing, you know how to turn your angular turn, you know how to interpret the 3-digit bearing, which is this in the options, and the cardinal bearing, which is also the compass bearing. I'm not going to have any issues with bearing. So that is all I have now. In my next video, I'm going to solve questions on distances. Simple examples before I move to the little bit much complex one, so that you understand it very, very well. So take your time, go through the video, follow everything I've said, take your paper, make sure you do the sketch yourself. If possible, use your protractor. Get these angles, you'll see that they are very simple and it's accurate and perfect. So for now, Take care.